come back to the next topic. General electronic configuration, short form GEC. So n minus 1d raised to the power 1 to 10 and ns raised to the power 0, 1, 2. 0 to 2 means 0, comma 1, comma 2. So this is called the ultimate shell. That is outermost valence shell is called ultimate shell. This is last shell. Before the last shell is called as a penultimate shell. In this penultimate shell, it is incompletely filled. So here our last shell is maybe incompletely filled with the zero no electron and one electron or a two electron. So last shell is called as a valence shell. It is Ns. And next to that before the last is called N minus 1d. That is called penultimate shell. Penultimate shell just before the last shell is called penultimate shell. For example, in your classroom, last row students are called as a valence shell. Before the last row, for example, in your classroom, 5 rows are there means fifth row is called as a valence shell, that is called ultimate shell. Fourth row is called as a penultimate shell. Then third row is the just before the penultimate shell, that is called anti-penultimate shell. Anti means before, so it is called as a anti-penultimate shell. So third row is called as a anti-penultimate, fourth row is called as a penultimate shell, fifth row is the last row is called as a ultimate shell. It is called valence shell. So again and I am saying last shell is called as a valence shell, that is called ultimate shell. Before the last shell is called as a penultimate shell. Imagine this is fifth row and this is fourth row. This is a third row means last row is called valence shell. Before the last row is a fourth row is called as a penultimate shell. Before the fourth row, that is third row, that is called anti-penultimate shell. So this is nucleus. This red one is nucleus. This is we can write a lot of energy levels. We need only two. That's what I have written: last shell and the penultimate shell. So let us see the question. D block elements in 12th group or second B elements. That is nothing but zinc, cadmium, mercury and copernicium. So the nearest noble gases argon, 18 elements. So D10, 3D10, 4s2. This is belongs to second transition series, 4D10, 5s2. This is third transition series, 5D10, 6s2. This is fourth transition series. This is 6D10, 7s2. They are not called as a transition elements because they do not have incompletely filled d orbitals. I already told you. So due to the stable reason, due to the stable electronic configuration, and DD transition is not observed in these two. I mean these two reasons, they are not considered as a transition elements. They are called as a non-transition elements. Except these elements, all other elements are partially filled d orbitals. D orbital elements in penultimate shell, that is n minus 1d, is a progressively filled with 1 electron. Single electron only is filling in a d orbital, that is 1 to 10 electrons are gradually it is filling. That is, and let us see the y ns orbital having 0, 1, 2 orbital. Let us see in the electronic configuration. So in this n minus, very important question is transition elements. D block elements are called as a transition elements. They are filling the electrons with the unity. One by one only it is filling and removing the electron to get an oxidation state. That too it is a one by one. But in case of non-metals, it takes the two metals, two unity. I mean by unity. Two electrons to be released. So we'll get a double. Plus 3 means plus 5 we will get. Plus 2 means we will get a plus 4 oxidation state. So that is one of the important point of getting the oxidation state. I mean adding one electron. No? By unity is a gradually we should add one electron. Removal of the electron also one. So this is the full electronic configuration of the 3D series, first transition series, second transition series, third transition series, and fourth transition series. First transition series are related to the argon noble gas. Second transition series related to krypton noble gas. And this is 18 electrons and this is 36 electron, and this is a 54 electron, and this is 84 electron. So these are the transition elements stability. Comparing this the electronic configuration of noble gases, they are a arrangement of alignment of electrons are present in the electronic configuration of all the series. So see, I have written in a box type, that is under exceptions. So chromium is a 3d4 supposed to be, but it has 3d5, 4 is 1. And copper 3d9, 4 is 2 supposed to be, but it has 3d10, 4 is 1. In order to attain a stable electronic configuration, they have aligned themselves. So here the chromium, that is what niobium, 3 should come. 4d2, this is 4d3 should come, but instead of being 3, it is a 3d4, 4 is 1. Same way, palladium. Then platinum. Platinum, you look at this here. This is, I'll just show you. This is palladium. You just see this 4d10, 5 is 0. So because of this only, I have written that ns orbital contains 0, 1, 2 electrons are present. But not any other elements will contain a in s orbital 0. Only this has 0. To attain a stable electronic configuration, and this also it is 9 1 and d10 or 6 1, I mean 5d10 6s1, and this is 5d9 6s1, and this 6d10 7s1. See, when you see all this is very difficult to by heart. So I'll give you the tricks to you to write whatever the question they will ask you, apply the trick and then you write the immediate answer. General electronic configuration, that is n-1d 1 to 10, that is ns 0 to 2. For example, scandium 2 plus. Scandium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So this is up to, this is electronic configuration of scandium 21. Then let us see later on the oxidation state. This is according to the atomic number. How to write the electronic configuration is 1s2, 2s2, 2p6, 10 electrons, 3s2, 3p6, 8 electrons. And here this is 4s2 and 3d only, the electrons will be getting inside or losing electrons only in these two only takes place. So this is called 10 and this is 8. That's what it is related to the noble gas electronic configuration of 18. So what we cannot remove any electrons by this shells because these are very stable electronic configuration. So the electrons can be added or can be removed only this ultimate shell and a penultimate shell. So what are this technetium, this is scandium. For a simple example I have given to you. Later on we will see the tricks. Now we see, let us see the exceptions. I already told you Tc is a technetium and technetium means artificial. So this is one of the man-made element that is called synthetic transition element which was made artificially. In exam they will ask you which is a man-made element in the 3D series. Means you immediately you write a technetium. I mean any series, I mean the technetium is a second transition series that is a 4D orbital. So noble gas electronic configuration is ns2 np6. N-1d orbital are filled progressively. Progressively means adding 1 electron. Then continuously adding 1 electron, no jumping at all 2 electrons or 3 electrons immediately. So ns is mostly 2 electrons in the outermost shell, not beyond 2 electrons. So some of the elements, chromium, copper, niobium, molybdenum, technetium, ruthenium, rhodium, silver, platinum, gold, rohingenium, etc. having only 1 electron in the ns subshell. Then palladium, I told you no electron in a subshell. That's what it has a 4d10, 5s0. So according to the electronic configuration, we should see what stability and unstable we should see. So there is a sudden variations in the general electronic configuration. Why? For example, few examples are there. 4D and 5s in a niobium. So 4d4, 5s1. Instead of this, we are having what? 4d3. Instead of 4d3 and 5s2, it is supposed to be 4d3, 5s2, but instead of that, it has a 4d4, 5s1. One electron is shifted to d orbital. 4d and 5s orbitals are nearly equal energy. So what we have to apply for the n plus L rule, already studied in first year. So n plus L rule means 4d gives more energy and 5s have the less energy. So due to the diffused activity of 4d, diffused activity means what? The electrons will be spread out. If you are having one hall means the hall, most probably the students will spread out and sit. If it is in a room means it is compact. So imagine this is a room, compact electrons, and this is a hall. So in ground, so there are space is there. So what that is called diffused activity of 4d shell. D orbital will have a equal to this 5s and a 4d, n plus L rule. For example, 5s. N is equal, principal quantum number is called 5. The number present in front of the orbitals is called a principal quantum number. So 5, n is equal to 5. So if it is S means the L value is because n is equal to 1, 2, 3, 4 means L is equal to started from 0, 1, 2, 3. So if n is equal to 1, L is equal to, S orbital 0 and P orbital 1, D orbital 2 and F orbital 3. Like that it goes. So what L is equal to 0 for S orbital. So apply this answer. So 5 plus 0. N means 5, L means 0. So 5 plus 0 equal to 5. So next thing for 4d orbitals. So in this 4d orbital, apply n plus L rule. Same way, this is called principal quantum number, n is equal to 4. Then L is equal to d orbital. If n is equal to 1, 2, 3, 4, etc., L equal to 0, 1, 2, 3. So S means S orbital, L is equal to 1 means P orbital, L is equal to 2 means D orbital, L is equal to 3 means F orbital. So it is a D. So L is equal to 2. So substitute the 2 values. So 4 plus L is equal to 6. When you compare to 5 years, it has a 5 value. It is a 40, it has a 6 value. So it is a lower energy and this is a higher energy. So but the energy difference between these two, 5 and 6 is very less difference only. So what they are both having a equal. So here that is 2s and 3s. For example, I am saying how to apply n plus L for 2 years. For 2p or 2s, already I told you if it is a p means L is equal to 1. If it is s is equal to L is equal to 0. So n plus L apply here principal quantum number 2. 2 plus p orbital means 1, s orbital means 0. The principal quantum number 3. So L plus 1 equal to 3. For 3s orbital, 3 plus 0 equal to 3. Both are having the same value. If L plus n plus L value is same, higher the value of the n is highly high energy and lower the value is lower energy level. So what are this is a lower energy and this is higher energy. So only the lower energy level to be filled up first. So 2p orbital is smaller than the 3s. So therefore electrons are filling in a 2p orbital. Thanks for watching. Next video, let us see the tricks of general electronic configuration.